So let's look at the example where we want the sixth root of negative 64. As before, we are going to start off by z to the 6 equals negative 64. And as I did last time, I am going to replace this with r to the 6 cis 6 theta, and I am going to rewrite this as 64 times negative 1, because then I can equate the r to the 6 with 64, and then I can equate the real part with our real part of the complex number and the imaginary part with the imaginary, which happens to be 0. So this results in r equaling 2, and our base angle for 6 theta as before is pi, which would result in theta being pi on 6. Now I'm not going to draw an argand plane, we're just going to discuss this. If our base angle is pi on 6, we are looking for the sixth root, we need 6 solutions, therefore we need to divide the argand plane into 6 sections. That means we are dividing 2 pi into 6 sections. And we're going to add and subtract lots of these 2 pi and 6's until we get our 6 solutions. Now I could go and simplify this 2 pi on 6 to pi on 3, but then I need to keep in mind my fraction additions and subtractions. So my theta becomes pi on 6 plus 2 pi on 6. That would give me 3 lots of them. Then I would have pi on 6 plus 2 lots of 2 pi on 6's. That would be 4 pi on 6. Now that takes me to 5 pi on 6. If I add another 2 pi on 6, I go beyond pi. So now I need to subtract. That would be pi on 6 minus 2 pi on 6, pi on 6 minus 2 lots of 2 pi on 6's, that's 4 pi on 6, and pi on 6 minus 3 lots of 2 pi on 6, that would be 6 pi on 6. Therefore, my thetas are pi on 6, 3 pi on 6, which is the same as pi on 2, 5 pi on 6, negative pi on 6, negative 3 pi on 6, which is the same as negative pi on 2, and negative 5 pi on 6. 1, 2, 3, 4, 5, 6 solutions. Now there are our 6 thetas. Now I need to write my 6 complex roots. Z1 is 2, don't forget the 2, cis pi on 6. Z2, 2 cis pi on 2, and so on. Now, of course, as before, at this stage, rather than think about dividing the argand diagram into 6 sections, I could have written 6 theta is equal to pi plus 2k pi, and then theta equals pi plus 2k pi on 6. Now they're the same things, but just to remind you that this way of thinking is used when we look at polynomials and when we look at complex roots in a polynomial solution,